Alright, so let's put the supply and demand together. What I've done is on the previous two videos, I came up with these individual points for my demand. I came up with these 3 points. You'll notice as our quantity demanded, well, actually, I guess the way I like to look at it, as the price goes up, the quantity demanded has been going down. And on the supply side, as the price goes up, the quantity supplied goes up. Alright, so let's graph this. I'm not going to bother with any of the quadrants 2, 3, or 4 because it's not possible to produce or sell or a negative amount of items. It's also not possible to have, or it doesn't really make sense in general, to have a negative price, negative cost. So that's why it kind of makes sense to stick with the first quadrant here. I do want to make sure that when I'm setting this up, you know, my quantity was my independent variable, and my price is my dependent variable. So this is kind of taking the place of my x, and this is kind of taking the place of my y on my graph. I do want to make sure that I have my scales set up so that everything will be showing up on here. So I'm going to go, let's go 2, 4, 6, 8. That should work. And then for my prices, it looks like the highest price I have on here is $6.75. Let's go 2, 4, 6, 8 again. When you're setting up your graph, try to make sure your spacing is consistent, at least consistent vertically within the vertical and consistent within the horizontal. Those two don't have to match between them, but you do want them to be internally consistent there. So let's see, $2, $4, $6, $8, and this is, remember, 2,000 items, 4,000 items, and so on. All right, so 5.25 is right about here. 7, 3.75 is, let's say, there-ish. 3.75 looks about there. 3, 6.75 is about here. And let me just fudge this a little down right there. This line looks about like that. This is my demand line. Okay. My supply line looks like this. We have the 0.7. My cat is meowing at me. Hang on a second. Alright, I have the 0.7, 5.25. Let's see, that looks about here-ish. Oh, I probably should be a little higher than that, because 5 should be halfway between those. 5.25 is a little above that. 5, 3.75 is going to be about there, and 4, 3 is going to be about here. Alright, it looks like those 3 points are about there. Let me see if I can adjust that. No, I can't. Okay, whatever. So, this is my supply curve. So what this is showing is that, you know, you can see as your, well, like I said, I like to think of it as price driving quantity, not the other way around. As the price increases, so as you're going up on here, the quantity supplied goes up. But as the price increases on the demand line here, you can see our quantity demanded goes down. So this one has a negative slope, that one has a positive slope. It's a little confusing when you think about it in that way, the whole which variable drives which. But if you just graph these and just be careful to make sure you keep them straight, then you'll be good. So this point right here is of particular interest. This is what we call the equilibrium. So the equilibrium price is where the quantity supplied and the quantity demanded are equal. That's this point right here. And to find where that point is, what we're going to do is we're going to say d of q equals s of q. So we usually call this the equilibrium point because it's an actual point if you look at the graph. I'm starting out with the equilibrium price, though, because I want to figure out one of the variables first. So I'm going to say the what is this? The demand price, and this is the supply price. I mean, of course, the prices are the same, but it's the equilibrium price. All right, so D of Q was, I need to look to see what that was really quick. I believe that was 9 minus 0.75 Q. S of Q was just 0.75 Q. And to find the equilibrium quantity, it looks like I'm going to be finding, actually. I said the prices are the same. That's what I said up here, because this is a price, that's a price. When I plug stuff in here, you can see my variable is actually Q, so this is going to tell me what Q is when the prices are the same. So in any case, let's solve this by adding 0.75 Q to both sides. We get 9 equals 1.5 Q, and then we can just divide both sides by 1.5. We get 6. So that means 6,000 items. Q is 6,000, or Q is 6 rather, so we're talking about 6,000 items. This actually looks like it agrees with my graph. That is the equilibrium quantity. We just need to find the equilibrium price. What price makes the supply and demand the same? So to do that, we said that D of Q and S of Q are the same at this point, and that's what led us to come to the conclusion that Q is 6. So at this point, we can actually plug in 6 for Q into either the demand or the supply function. So let's actually see what happens here. If I plug in D of 6 is 9 minus 0.75 times 6. 0.75 times 6 gives us 4.5. So I end up with 9 minus 4.5, which is 4.5. So this 4.5, not 4.9. That's a price, so that would be $4.50. You'll notice if I was to plug this into S of Q, I'd get 0.75 times 6, which is, well, I just figured that out as 4.5. You'll notice that gives us the same amount. That was actually, by design, that these two things end up being equal. That's what I said when I said D of Q equals S of Q. I'm making sure that when I plug in some value for Q, I get the same thing out of it. And, well, when I plug in 6 for Q, I get the same thing. I get $4.50 out of it. So this right here is our supply, our equilibrium quantity. And this right here is the equilibrium price.